Now we're going to start getting into more solving equations with logs, but there are a few rules that we need to go over first. The first rule of logs is that if you have a log that does not appear to have a base, there's no subscript of a number down there, you have to assume that that base is 10. So if we have log of x and there's no base, that's the exact same thing as log base 10 of x. The next rule is called the product property. That says that if you have log with a base and some product inside of your log as the answer, we can split that up into two separate logs where we're adding them together. So when we can separate it, we would take what the product is. Those are each going to go into their own individual logs. We also have a quotient property, which is kind of the same thing, but instead of adding the two logs together, we'll be subtracting. So whatever is on top, that's going to go first, that's going to stay positive. Whatever's on the bottom, whatever's in your denominator, that log is going to become negative. And finally, we have the power property. Anytime you have an answer with an exponent in it, here we have this x to the n, that n can be moved to the front of the log. So then we have n times this log base b of x. So what we're going to do first is practice writing shortened, condensed logs into expanded form. We're going to make them longer expressions. So we have log base 2 of 3x. Whenever we're expanding, we're going to keep that base. We want to use a log base 2 every time. And so let's see what happens inside of our log. We have this 3 times x. We have a product. So we're going to use our product property. So to expand this, we're going to keep log base 2. And then I'm going to start with the 3 plus another log base 2 of the thing we were multiplying, which was x. That's the only thing we can do here, because we're only multiplying the 3 and the x, there's nothing else happening. In number 2, we have log of x over 4. Notice this one does not have that base there, so we can write that base as a 10. So I'm going to start by putting log base 10, and then my numerator is going to go first. Since it's a quotient, we're going to subtract the next log base 10 of our denominator. If we had something else in the numerator besides just an x, maybe like a 3x on top, we would have log base 10 of 3 plus log base 10 of x, and then the only thing we're subtracting is what's on the denominator. Now we have log of n squared. This is one of those power property logs where we can take this 2 and just move it to the very front of our log. Again, this one doesn't have a base, so I'm going to write that base 10. So this becomes 2 times log base 10 of n. And number 4, I've got a lot going on. I've got some products and I've got some powers. So what I'm going to do first is separate the products, then I'll worry about those powers. Our base is 2, so we have log base 2 of x cubed. It was a product, so we're going to add log base 2 of y to the 6. Then we're going to use our power property, so any exponents are going to move to the front of the log. This becomes log base 2 of x plus, 3 log base 2 of x plus 6 log base 2 of y. That right there is our final answer for that one. Now we have log base b of v cubed w to the 5th all over 5. So here we have product, we have quotient, and we have powers. I'm going to start by separating the quotient and product. I can do that all at once. So I have log base b. My products I'm adding, so I have v cubed plus log base b of w to the 5th. Those were both on top, so I'm adding them. And then whatever's on the bottom, we're going to subtract. So we have minus log base b of 5. Now I'm going to worry about those powers, moving them to the front of their respective logs. So this will become 3 log base b of v plus 5 log base b of w minus, the 5 didn't have an exponent, so we don't need to move anything to the front. So we're left with minus log base b of 5. In number 6, we have power to a power situations. And if you remember your exponent rules, if we have a power raised to another power, we can just multiply those exponents. So I'm going to start by getting rid of this 1/3 and rewriting this as log base 4 of 6 times 1/3 is 2, so I have j squared, and k to the 1, which is just going to be k. Now I'm going to worry about my product and my power. I'm going to do this all in one step now. J is the only thing that had that exponent, so in front of the log with J, I'm going to put that 2. K did not have an exponent, so I don't need to put anything in front of its log. And there's our final answer.